All right, we're going to take a look at an expression that comes up in an integrand when we're doing the arc length. This one is specifically rigged so that we can actually integrate it. Most functions, if we want to try to find the arc length of it, it's going to be fairly difficult. So we're going to start out with 1 plus the quantity x cubed over 2 minus 1 over 2x cubed quantity squared. And where we're going to go with this is we're going to expand that quantity squared, combine like terms, and then see if we can get a perfect square. If we can get that integrand to be a perfect square, then when we're plugging that into the arc length formula, the square and the square root will undo each other. So we're going to go ahead and expand that. So x cubed times x cubed will be the x to the 6th, and then 2 times 2 will be the 4. Then we're going to have 2 of x cubed over 2 times negative 1 over 2x cubed. So we'll have x cubed over 4x cubed. Of course, the x cubes are going to absorb. And then we'll have 1 over 2x cubed times 1 over 2x cubed. So that'll be 1 over 4x to the 6th. Okay, so we're going to go ahead and simplify. This turns into 1/2. That's what we have right there. Plus the x to the 6 over 4 plus the 1 over 4x to the 6th. Okay, so we're going to rewrite that as x cubed over 2 squared plus 2 times 1 over 4 plus 1 over 2x cubed quantity squared. Everybody's got a 1 over 4 in common, so we're going to factor out 1 over 4. And so what you're going to have is x cubed plus 1 over x cubed, and we can, let's go back. We can go ahead and expand that to double check that that is in fact what we think it's going to be. Okay, so let's just expand the x cubed plus 1 over x cubed squared, and then we have the 1/4 there. So we'll FOIL that out. So you got 1/4, and then it's going to be x to the 6th. And then when we multiply this and this, the x cubes are going to absorb, so we're left with 2, and then plus 1 over x to the 6th, which is exactly what we got right there. So this is valid. Okay, so we're going to go ahead and apply this in an arc length problem here. So let's say we want to find the arc length of y equals x to the 4th over 8 plus 1 over 4x squared, and we want to find the arc length from 1 to 3. Of course, we need a continuously differentiable or smooth function in this case, so we have a polynomial and a rational function. The rational function only has an issue at 0, and the x to the 4th is a polynomial, is continuous everywhere, differentiable everywhere. So on the interval 1 to 3, we have the requirements for arc length. So we need to take the derivative. So y prime is x cubed over 2, and then minus 1 over 2x to the 3rd power. Your arc length formula from a to b is going to be 1 plus y prime squared under the square root dx. Okay, and so what we'll go ahead and do is we'll plug in our limits and our y prime. So this will be 1 to 3, 1 plus x cubed over 2 minus 1 over 2x cubed quantity squared dx. And this right here is precisely what we spent a couple minutes on that first slide kind of figuring out what that is. So again, the goal was to make that into see if it was a perfect square. If it's a perfect square, then we'll undo that square root. So from our work on the last slide, that's 1 to 3, the integral from 1 to 3, the 1/4 x cubed plus 1 over x cubed quantity squared dx, and we can go ahead and simplify it. So the square root of 1/4 will be 1/2, and we can go ahead and factor that out of our integral 1 to 3, and the square root and square will absorb, so then we have x cubed and then x to the minus 3 dx. Now it's just power rule, so we'll go ahead and integrate. So we have 1/2 x to the 4 over 4, and then it would be plus x to the minus 2 divided by minus 2, or we can write it as minus x to the minus 2 over 2, and evaluated it from 1 to 3. and that's going to be about 10.22. I'll leave it to you to verify that is in fact what that arc length is. Okay, so again, these have to be specifically rigged so that they'll work out like this. So I'll probably end up making another video or two of these kind of techniques that we got to do to find the arc length here.